So I want to pick up where we left off. So with this class, I've talked about, I don't know how it worked out, but now you guys have, you in 8th period, you're on the same page now. So we talked about 3 subatomic particles. What's 3 subatomic particles? Protons, neutrons, and electrons. Those are the 3 subatomic particles, and those are what?
And also, go Mountaineers.
Those are what make up atoms. So we're going to focus in on those, and they're very important, very crucial for different things within chemistry. So today we're going to, I talked about the element names, right?
Yeah.
Talked about atomic number, right?
Yeah.
Talked about the symbol, right?
Yeah.
Never got the average atomic mass, right? Oh, wonderful, wonderful, wonderful. So I've given you all periodic table, correct?
Yeah.
Oh, very nice, very nice. So over on the periodic table, don't worry about electronegativity. We will discuss electronegativity later. But what we have, the last one we're going to talk about is average mass, which is actually called average atomic mass. Now, average atomic mass is something very special. So this is what average atomic mass will do. Let's say I took all the carbon in the universe and I piled it all together. What you will see is there's something you will learn about today called an isotope. Isotopes are of atoms of the same element. So it's kind of like people, right? We all people, right?
Right.
Yes, yeah, thank you, thank you. Okay, I told you, come to class, woke up, ready to go. Why didn't you drink coffee? Why you know ready to go today? Come on, people. It's almost quiz day, right?
Yeah.
So, we're all people, right?
Right.
There we go, I got more involved. Hallelujah. So, since we're all people, we're all classified under the same categories, but we all look different, sound different, we talk different. People are different, right? Well, it's the same thing with atoms. Like a perfect example. Okay? Elijah, can I use you for an example? Look at Elijah and compare him to me. Yes, I want you to think of what you're thinking right now. Elijah is skinny. Mr. Hall is wumbo. Mr. Hall, very wumbo. Okay? Is Elijah a person?
Yeah.
Is Mr. Hall a person?
Yeah.
Elijah is small. Mr. Hall is wumbo. He's very big. He can make it out to be a sumo wrestler. Right? It's okay. I get it. I'm working on it, alright? So, this is what average atomic mass does. Average atomic mass takes an element's isotopes and percent abundance into account to calculate an average mass for us to use. So here's the thing that you got to wrap your head around. You got isotopes. Isotopes are atoms of the same element. But different mass. So I'm going to pull on you a little bit. Whenever I'm saying the same atom, that these atoms are the same element, what does that mean? What subatomic particle is unchanged? The proton. Why the proton? If you change the proton, you've changed the atomic number. If you change the atomic number, you change the element. This is how chemistry really got its start. It started out as alchemy. And everyone was like, let's turn stuff into gold, because gold's valuable. So you had people that literally were looking and like, P is yellow, gold is yellow. If I just heat it up, I'll have gold. I know what you're thinking. That was back like a long, long time ago. Don't worry, chemists are a lot smarter nowadays. So they did this process. They ended up with this white powdery substance, which is very interesting because as soon as it would dehydrate, it would erupt into flames. This was phosphorus. White phosphorus to be more exact.
Come from P?
Yeah. Takes a lot to get it though. You're not going to go home and do this. So here's the thing. The proton stays the same, but it has a different mass. So we got a problem. Where does the mass of an atom come from? The proton can't change. So that's interesting. What are we going to do there? So let's go on a little journey where the mass of an atom comes from, but I ain't writing it all out. So here's the thing. You have 3 subatomic particles, right? So we've got that narrowed down. We've got the proton, the neutron, and the electron. The thing is, you get into very interesting dilemmas whenever you start looking at them. Because the mass of the proton and an neutron, sorry. So the mass of a proton and a neutron are nearly the same. However, the electron is much smaller. And this is why this is important. So the proton can't change, right? The electron is much smaller. So where do we get the mass change within our isotopes? The neutron. Very nice. So the neutron is what changes. So this is kind of the way to imagine it. And this is how I like to explain it. Let's say we work at a zoo. We need to get an accurate mass of an elephant. So we put an elephant on a scale. Now, is an elephant mini or wumbo?
Wumbo.
Wumbo. So we get the elephant on there, we get the mass of it. We're walking off. Yeah, we got the mass. Oh, snap. Somebody's like, what? Man, there's fleas on my elephant. Dude, I can't have an accurate mass if I got fleas on an elephant. So we give it a flea bath. You know, raises the trunk up, it's so excited. We get the fleas off, they all dead, they all gone. We put the elephant back on the scale. What are we going to see?
Water.
you're not going to see a change. That's right. Why are you not going to see a change?
Because it's very small.
It's so small. Why? Compare a flea to an elephant. The flea is very, 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 very many, while the elephant is very, 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 very wumbo. So, literally, the electron doesn't even matter. Does nothing in terms of mass for us. So here's what I want you to get. What changes in terms of isotopes? The neutron. When we're changing mass of our elements, of our isotopes, we are changing the number of neutrons. And this is very important. So now, we get to focus in a little bit on this average atomic mass. So we're going to look at how to map average atomic mass. So today we will talk about one of our favorite elements. We all love it. I don't want to play the podcast. Thank you. I want my isotopes. They have changed my app for me, and I do not like it. You piece of trash. Yes.
I thought the electron had like an E and a negative top and then a negative 1.
It does. I just didn't put the 1 with it, I just put the negative. Alright, hold up. We gotta go with an alternative option here. Why is it though? That's why you're supposed to check and make sure your technology is working the way it's supposed to work before you start to use it for class.
Your YouTube videos didn't work.
One YouTube video didn't work. I told y'all wait on the other two. Y'all.
Did you not see the message at 10:38?
Yeah. And it said, y'all go ahead and get some sleep now.
Yeah,
At 11 o'clock.
How many of y'all were asleep? I am shocked.
I went to sleep.
Okay, so we're going to talk about this. So the first thing you need to know is the mass number. So the mass number is the mass of that isotope. It's another way for us to show an isotope. I'm going there yet. There we go. So we can show this in various different ways. So one way we'll do it is we'll do it with the symbol. So let's choose carbon. So we'll do the symbol, and then we'll stick a number with it. So we can stick the number here. I can stick the number here. Or I can also put a dash and a number. But here's the cool thing. I'm going to do the number here. Reason behind this. You look at carbon. And I say carbon 12. This is name. I gave you the element's name. Since I gave you the element's name, can you give me the number of protons?
12,
No.
6.
Look at your periodic. It's 6, yes.
Oh, okay, I did that.
Okay. How can you find the element's number of protons based off its name?
You just add, subtract,
I literally gave it to you.
you look on here.
On the periodic table for the
The little number above the letter.
atomic number. Thank you, David. The atomic number is what will tell you. What is the atomic number for carbon?
6.
So I can put a 6 here. Now, the cool thing with carbon is there's 2 other isotopes. So I have a carbon 13, and the one that everybody is like, oh, it's so cool. Carbon 14. With these, how many protons does carbon 13 have? Why you say 6? It's carbon 13 though. The mass changed, so there has to be a change in the mass.
No, because the neutron changed and the protons didn't change.
Exactly. Protons stay the same because we're still dealing with carbon. What changed?
The neutron.
The neutron changed. What about carbon 14?
6.
For the love of God, it's carbon 14. Why are you saying 6?
Because the number of neutrons changed, not the protons.
So happy they're getting it. Everybody else is giving me blank stares like, you're speaking German to me today. Yes, proton stays the same. Why is the number of protons staying the same? Because the element didn't change, so the atomic number can't change. The atomic number is the number of protons. Therefore, it doesn't change, so it stays the same. See? Y'all still looking at me like I'm speaking German.
Mr. Hall, it's not C, it's carbon.
Boom. Now here's the important thing, and I'm going to show you the trick for how to figure this out. Whenever you have these are the 3 isotopes of carbon. In the universe, we can look and we know the percent abundance for them. So out of 100% of carbon in the whole universe, a certain amount of it is carbon 12, a certain amount is carbon 13, a certain amount is carbon 14. I will have to give you this information. So the percent abundance for carbon 12, 99% of carbon in the universe is carbon 12. Percent abundance for carbon 13. 1% is carbon 13. Now before y'all start throwing shoes at me and throwing a fit, Mr. Hall, that's 100. You got nothing to ask for carbon 14. I'm so happy your math skills are that advanced and great you'll kill the SAT. Carbon 14. You gotta give me a second. Okay. Is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1.
I was writing down 1, 2, 3, 4, 5, 6, 7.
I'm sorry, I had to count it out. I couldn't do it. Is 0.000000001% abundance. There's 9 zeros after the decimal. So how much of our carbon is carbon 14? Practically none. Is it there? Yes, but it's practically none.
1 to the negative 10th power.
I'm looking for it.
So, you're looking at this information. I'm going to show you how to math an average atomic mass. You like that, don't you? I tell you how we're going to math it. When you're looking to math, I love how I've taken a subject and made it a verb today. Across the curriculum, I mentioned an English term. Mark it off. When you're looking at doing this, this is seriously what you're going to do. The average atomic mass takes the mass and the percent abundance into account. You're going to find the summation of those values added together, multiplied by the percent abundance. It'll make sense to you. I know it sounds really confusing. Step 1, find your percent abundance. Don't you dare cuss in my room. Don't you do it. When you are down in Miss Cole's room, you can do your scoop method. Do not cuss me. When we do math properly. We divide all of our percentages by 100. Now you're looking at me and go, well, Mr. Hall, what are you doing? This is the scoop method, okay? If I was going to take a percentage and make it into a decimal, you all going to want to do the scoop method, but that's not good math, okay? You get the right answer and it's a trick, it's wonderful, but I want you to make sure you know in your brain what you are doing. You're dividing by 100, you're not moving the decimal places by 2. So here we get 0.99. Here? .01. Here, we get 0.70 after the decimal. 1, 2, 3, 4, 5, 6, 7, 1.
How'd you get 7?
You're dividing it by 100, so it's going to take 2 of them off. There was 9. Or if you use Miss Cole's scoop method. 1, 2. Decimals there now.
I don't know the scoop method.
It was funny, the whole joke in class that I say that now came up because I told the kids, don't tell me you just move the decimal. You can't just pick something up and move it. You have to do proper math to do it. And they told Miss Cole, whenever she was doing the scoop method, one day in class, they told her about it, so she found me. She said, I've been told you don't like my scoop method. I'm like, what are you talking about? So she explained it to me, and I said, I hate that. I hate it when the kids tell me to do that. You're not just moving the decimal. You can't just pick it up and move it. I said, well, it works better. Now this is what you're going to do. You're literally going to take the mass number and multiply it by percent abundance. Mass number, multiply it by percent abundance. Mass number, multiply percent abundance. You're going to add them all together. So this is what it's going to look like. The average atomic mass. I'm just going to say average mass for carbon is equal to, I'm parentheses free. I'm going to use my parentheses like crazy. What's the mass of carbon 12?
12.
Yeah, it's just 12. Now, here's the thing. What matters in science?
Units.
Units matter. We got to have units on here. So you got a couple different options you can do. One is atomic mass units. AMU. Now, for what we're going to be doing, I guarantee you we're going to do it tomorrow. I hope we can touch it today. AMU, I really don't like those. I like grams per mole. We multiply that number by the percent abundance, but it's the decimal of the percent abundance. Do not multiply it by 99. This is where you're going to make the mistake. I'm telling you, there's kids in this room, you're going to make the mistake. I'm stressing it to you right now. You're going to wish you would have had that coffee and you listened to Mr. Hall today. You multiply by the decimal of the percent abundance. So 0.99. Then we will add to that, parentheses, 13 grams per mole. times 0.01. Why do I not multiply by 1?
Because that's not the percent abundance.
It's not the decimal percent abundance. Multiply by the decimal of percent abundance.
Where'd you get the 13 from?
What's the mass of carbon 13?
13.
Beautiful job.
It's 13.
Plus, what's the mass of carbon 14?
14.
14
Grams per mole.
grams per mole. Let's show y'all catching on fast.
Times
Times
the whole number.
Point 1, 2, 3, 4, 5, 6, 7, 1. Once we do this, I'm just going to type it all on the calculator. Time for a timeout. I worked on my calculator.
How you talking about the calculator though? You put 12 times 10.
Parentheses, 12 times 0.99 in parentheses plus parentheses 13 times 0.01 in parentheses plus parentheses 14 times 0.2, 3, 4, 5, 6, 7, 1 in parentheses, hit enter. Whenever I do this mathematical property, I get 12.0100 grams per mole. Question to you, off your periodic table, what is the average mass of carbon?
12.01.
You know what I just did? I gave you a nice little check system for you. You do the math, check with the periodic table. Now, can I be honest with you? You can get a little off. If you're like the decimal point off or something, not a big deal. If you're like a whole single digit, like in the ones place, if you're that far off, you better check on that again. Yeah, you made a big one-boat mistake. Got it?
See, senorita. Hey, I just about failed Spanish, so you can't blame me.
I'm insulted.
We apologize though.
Okay. How you guys feeling? Alright. I'm gonna give you one. I'll give you like 2 minutes to work.
Oh my gosh, Mr. Hall!
I have a question.
What?
How do you know how many isotopes an element has?
I give those to you.
Okay.
Okay, so let's look at the isotope. And let's look at the percent abundance. This is the information I will have to give you. Let's do copper 63 and copper 65. .17% and 30.83. There you go. Give it a shot. I only gave you 2 because it should not take you that long. So, hey Siri. Hey Siri. Hey Siri. Thank you. Can you please start me a timer for 2 minutes?
2 minutes, starting now.
Woo! Yes.
Is that 69.17?
It is. I have made an executive decision that the orange marker is now trash because it is trash.
Yeah, we kind of
What's
reflecting
below
off the
it? I
line.
can't see it.
Shh. Don't tell anybody I have my markers in my first aid kit. This one's copper 63. This one's copper 65. Percent abundance for copper 63 is 69.17%. Percent abundance for copper 65, 30.83%. still working, finish it up. I want you to finish. I want you to attempt it and try it. What in the what? That is trash. That is more trash than the orange.
He tries. He come to work today. Doing good. He just
Yeah, it's okay. He's in the trash now.
Quiz or no honey quiz? I had to ask. If I didn't ask,
Y'all want to answer that?
I would forget
What is
myself.
it?
No.
No.
Hey,
How many of y'all got 63.6166?
That would be what I got.
I'm still working.
That would just be.
All of you that just raised your hands, is this the answer that is on your paper? Because if it is, you are 100% incorrect.
it's not.
Why?
Because the decimal's wrong.
No, you didn't put your units, and the units matter.
I'm so proud
I
of
have
you.
units on mine, you
Oh, I
want
have you.
Oh,
I got tears in my eyes because I feel so much proudness of y'all. That may not be in proper English, but I don't care. Y'all killed it today. That's grams per mole, right?
No.
Yes, sir.
How many of y'all got that?
Me.
That's a beautiful job. Now why is this 100% correct?
Units matter.
Because the units are on there and units matter. So proud of y'all. Good golly tamale. Okay. I have great news. First, Mr. Hall has a gift. I have other news that you will look and say, wow, that is great news.